Okay, example 5. Find the approximate area of the region bounded by the curves y equals 4 sine of x and y equals x minus 1. And I think we got an advanced look at this in the homework section because I didn't pay close enough attention to the ones I picked. This is one where this is on top some of the way and this is on top some of the way. They switch, so we have to figure out, what's on top, what's on bottom for each location. So if I start by graphing, I can clear out all these. Alright, so y equals 4 sine of x, and I notice I'm in degrees, not radians, so I want to make sure I change to radians, because we always graph radians in calculus. And is it y equals x minus 1?
Yep.
Covered up here, x minus 1. And let me fix the color on this one. Go back to red. Alright. Again, I'm not quite sure where it goes to. So if I just do a zoom 6 to begin with, if I want to get closer I can. So there's the 4 sine of x. And there's x minus 1. Alright, so it looks like everything happens between -3 and, let's go, 3. And -4 to 4. So if I just zoom in, -3 to 3. And -4 to 4. Here's my 4 sine of x again. And there's x minus 1. So everything we need to see is right there. And what I want to bring to your attention, let's take that down, is that for this region here, the line is on top, so x equals some number here, and x equals some number there. For that interval, the line minus the curve is going to be the area formula. And for the other region, which is right here, we got the curve on top, starting at the same x here and ending at this x, whatever that is. Alright, so from -2 point something to negative point something, and from negative point something to 2 point something. But sine minus x minus 1, x minus 1 minus sine, so just the order of subtraction changes on those. So what you want to do is construct an integral for this part, and add that to the integral for that part. The two areas add together to get the total area. So with that in mind, I need to figure out those x's. So if I do Calc 5, there's only 2 curves this time, so just enter, enter. All right? And then as far as the guess, that one's about -2.2-ish. -2.2101. The next point of intersection, second Calc 5. Enter, enter, I'm going to guess -0.3. It's -0.3422. And finally, second Calc 5, enter, enter, and guess about 2.8 maybe. 2.7021. So I have everything I need to know now. I know the top function, I know the bottom function, I know the intervals. So I just construct an area formula for each one. So for this interval, it's going to be from -2.2101 up to -0.3422. That's going to be the line minus the curve, so the line is x minus 1. We're subtracting the curve 4 sine of x. For the second piece, we're going to start at -0.3422, go up to 2.7021, and that's the curve first, 4 sine of x, minus the line second, minus x minus 1, dx. Again, construct your integral the same way you always do, just create one for each region. Good, probably just get rid of that. Well, that's not good. 2.702, this does not want to cooperate, all right. So, all right, so, if I simplify each one's, and I'm gonna actually, let me do this. So I'll do a blue one and a red one so we can see the differences. So if we take a look at the blue one, it's going to be negative 2.2101 up to negative 0.3422. And it's just going to be x minus 1 minus 4 sine of x dx. If I go ahead and work that one out, it's going to be x squared over 2 minus x plus 4 cosine of x. Antiderivative of sine is cosine, cofunctions change the sign. And the 4 is just a constant multiple, so it doesn't affect the antiderivative at all. We're going from negative 2.2101 up to negative 0.3422. And to that we're going to add this integral, which is from negative 0.3422 up to 2.7021. And it's 4 sine of x minus x plus 1 dx. So the antiderivative of this is going to be negative 4 cosine of x minus x squared over 2 plus x. Those two antiderivatives are just the same exact things, just opposite signs in every object. It's not a coincidence, that's how it should happen. So then, we simply have to evaluate each one of these. My calculator is going to help me because I don't know what all this stuff equals. What I would do personally, I think I've already shown you this, but I'll show you again just in case. Go here. I'm going to type in negative 0.3422 store x. So what that's doing is it's telling my calculator anytime I hit the button x, I mean negative 0.3422. I'm going to put a colon, which I believe is second decimal point. Nope. Alpha decimal point? Yep, alpha decimal point. Colon. So what the colon does, I've given it a command, now I'm going to tell it to evaluate something. All right? So I'm going to evaluate x squared divided by 2 minus x plus 4 cosine of x. I hit enter, and it tells me what that is. So what that represents is when I put this number in, I evaluated this, I got 4.1688.
Could you just put that equation into your y1 equals and put the negative 3.422 in your table?
Yeah, that would work too. Yeah, if you were to put this as y1 and put that in your table, that works.
Mm-hmm.
If I'm evaluating like 10 things, that's the way I do it. I'm only evaluating 2.
Mm-hmm.
I'm going to show you the reason why this is useful is now that I want to evaluate the next one, if I just hit second entry, it brings up the same exact thing.
Mm-hmm.
All I have to do is change this number to that number. It's already got the x expression typed in. So just evaluating a couple things is easy enough to do it this way, but your method works too. So negative 2 point, and there's one extra character to the right. So if I go 2.21, oops, 2.1, oh, I run out of space, just hit insert, get that extra space in there. We get 2.2658. So when I put this number in, I get 2.2658. So that just is this expression evaluated for both of those things. All right. Now I need to evaluate this one. Which, slide it over just a smidge. Yeah, just doing all the buttons good. All right, so this one I'm going to go 2.7021 store x alpha colon negative 4 cosine x minus x squared divided by 2 plus x. Enter. And I get 2.6713. So when I put this number in, 2.6713 minus something. And then I do second entry, backspace. On the old TI-83 Plus, if you press up, it would go to the beginning. if I press up here, it doesn't the one before it, so one disadvantage of these calculators that I found. So it's negative 0.3422, just enough characters, that's good, hit enter, we get negative 4.1688. So haven't used radian. So minus negative 4.1688. So we get all that stuff. So the answer to get this is just this minus this plus this, then it'll be plus this also. So I just have to type those in. I mean, I could do that by hand, but it's quicker to do on the calculator. So 4.1688 minus 2.2658 plus 2.6713 plus 4.1688 equals 8.7423. All right, the main idea of this problem, again, is the fact that it's not always going to be something's on top the entire way through. So if you see a picture like that where one's on top for a while, then another one's on top for a while, and it might even switch back again because, you know, going back to the Zoom 6, side just keeps going up and down and up and down and up and down. So depending on the angle the line's hitting, it could actually shift several times. I'll give you an example of one real quick. That one only hits twice like that. If the equation had been, let's say, y equals x over 2 minus 1. We should just keep that one, that would be better. But we'll wait patiently here. Oh, good, I did make it. So top, bottom, top, bottom, top, bottom, top. It just keeps switching. So each time it switches, you have to create a new region. So from here to here, line on top, here to here, sign on top, here to here, line on top, here to here, sign on top. So however many regions I make. They usually don't go beyond 3, but you know, depends. I didn't put any thought into that one, so it happened 4 times. Again, that's the whole idea, is to make one integral for each region that you can identify top, over, or bottom.